I wanted to put up a screencast on some of the points that I didn't have time to mention in class when we worked on these production possibility application exercises. One thing I wanted to point out is that as we graph the production possibility frontiers, it turns out for this purpose, it doesn't matter whether students put wings on the y-axis or put wings on the x-axis. For this type of graph, it doesn't matter. You get the same answer either way, and you'll get the correct answer if you do it carefully either way. Later, starting in our next unit, supply and demand, it will matter very much that price always goes on the y-axis and quantity on the x-axis. But for these production possibility frontier questions, it's just somewhat of an arbitrary choice. I wanted to tell you, and I'm just going to do it in miniature here, the easiest way to do these simple production possibility frontiers is to figure out what VV, let's say we'll start with VV, can do if she specializes completely in wings. So let's say this is wings per day, and this would be pizzas per day. The easiest way to do these is to figure out how many wings VV could make in a day. She's working 10 hours. Look at how much hours per day. This is a daily production possibility curve. And these productivities give her pizza and wings per hour. So if she's working 10 hours a day, she could make 30 orders of wings if she just made wings. Or if she just made pizza, she could make 10 pizzas. And then it turns out there's an infinite number of combinations of pizzas and wings that she could make, assuming we could split wing orders into fractions of wing orders. Anyway, you can just connect those dots and you'll get her production possibility frontier. I think that's it. The other thing I mentioned to a lot of groups is draw to scale. So if you were going to go, this is VV's. If you're drawing David's, pardon the clutter here, or once you make your choice about axes, keep it consistent. Anyway, a VV can make 30 an hour, and we've shown it that way, and David can only make 10, per day. David can only make 10 orders per day. Make sure that you scale the axes roughly to scale. So this 10 on David's y-axis is approximately 1/3 of the way up the 30 for VV. And then since David can also make 10 pizzas per day, we'd want to make sure those distances between the origin and the 10 were approximately the same. Obviously this is pretty rough, but I have an answer key put up later where I've used graph paper and done it much more precisely. But getting it roughly right, we can see right away that BB's opportunity cost of a pizza is much higher than David's opportunity cost of a pizza. Notice that the slope of each production possibility frontier, this is -3 wing orders per pizza order for VV. This is -1 wing orders per pizza for David. Notice that the slope of the production possibility curve written in this space always tells us the opportunity cost of the good on the x-axis. And it's always also the reciprocal of the opportunity cost of the good on the y-axis. It's actually students, I find this is the easiest way for students to never make a mistake on calculating opportunity costs, is to just read the slope of the graph and then take the reciprocal for the opportunity cost of the other good. So the opportunity cost of wings is 1/3 of a pizza per wing order for VV, and for David it's 1 pizza per order of wings. All right, I've got all that in the answer key that is both on my slides and on my at the end of the screencast. All right, the other thing to note is the productivity information for this kind of problem might come in output per unit of time input, or you might get the information in the time input per unit of output. Notice that the one is the reciprocal of the other. Both of these forms of productivity information give you the same information, but you need to pay attention to which information you have in order to proceed and do whatever is being asked of you to do correctly. Oftentimes, you're to use this information on productivity. Oftentimes, you go right to a question about comparative advantage. And to answer the comparative advantage, you need to make this table about opportunity costs. And one simple way is, again, to draw the production possibility curves first. Sometimes there's a multi-part question that doesn't come around to opportunity to the graph till later, but you can always do that first and then read your opportunity cost off that. But you can also think it through this way. Let's suppose that, let's take Vivi, and we want to think of her opportunity cost of wings, say. Well, remember, opportunity cost is always equal to what we give up over what we get. And then, so with that in mind, if we're looking for the opportunity cost of wings, let's use it. Let's think it through in this format first. Well, think about Vivi moving 1 hour of her time out of pizza production and into wings production. So she'd give up one pizza per, and she'd get 3 orders of wings. So it's 1/3 of an order of a pizza per order of wings. And we see that, you know, we would have entered that in the table. Now, if we wanted to go here, let's think about this. 1 hour per pizza, 20 minutes per order of wings. So if she gives up, again, we'll do what she gives up. Let's just say she gives up 1 pizza, and what's she going to get? Well, she's got an hour that she's moving over into wings, and notice it takes her 20 minutes per order of wings. She'd get 3 orders in an hour, given she's moving 60 minutes over there. So again, 1/3 of a pizza per order of wings. So you can get it off the tabulated information in either form. Keep your wits about you. It's practice is what turns this from being a hard problem to being an easy problem. And because that's where we started. But the trading price simply needs to be, if we think about the price of a pizza, we see that the low cost maker of pizzas is David, and it takes him 1 order of wings to make a pizza. And the high cost maker of pizza is Vivi. So the low cost maker is 1 order of wings per pizza, high cost 3 orders of wings per pizza. You need a trading price somewhere between there, and 2 fills the bill and is an easy number to work with compared to like 1.7 or 2.3. We could do it, right? We've got calculators, but I just picked that 2 because it was between those 2 opportunity costs. All right, I moved on to ask about the trade possibility curve, and I didn't spend much time thinking about where that trading price came from. I'll just tell you that if we're thinking about a trading price, we want to. I've given you the productivity information. Anyway, I have the answers here. I went over them in class, but I've got them in this screencast too. Here is Vivi's production possibility frontier. Let me pick a blue color because it'll stand out. Notice that in that first part, I think I had you label that point A, so I'll label that. Point A, that's where they're splitting 50-50. With trade, Vivi has the comparative advantage in wings, so she'll specialize completely in wings. And then her trade possibility curve is given the price of pizza, the consumption possibility set that she can reach with trade is this trade possibility curve. And notice that the consumption set has expanded with trade. That's the gains from trade. We actually need some tools about Vivi's preferences to know which of these points she would choose. But one way to think about the gains from trade is to notice that from point A, there's this whole range of possibilities where Vivi has both more pizza and more orders of wings, more of both goods. We assume human preferences are such that more is better. So this is Vivi's completed PPC and TPC given the productivities provided. Notice again that the slope of the PPC is the opportunity cost of production for the person in question. The slope of the trade possibility curve is the barter trading price. How many wings must be given up to get one more pizza? Excuse me. Both Vivi and David saw it as a trade situation where the prices are really different. We'll notice that the more different prices are from no trade, more different the trading prices are from the no trade prices, the bigger the expansion in the consumption possibilities, and so the greater the gains from trade. This is David's answer, David's production possibility curve. And then I had one more application that we didn't have time for. Here are trading prices pretty different from their no trade prices. But sometimes you get a problem where one party to the trade faces trading prices that are pretty similar to their no trade prices, and the other party however, and that's who gains more. And there's a few ways to answer that. D is a defensible answer, for example. If the best answer here, and this is just looking ahead to later work that we won't get to in this course actually, but in the course, the next course in this sequence is Economics 327, and we spent a lot of time with thinking about what consumer preferences look like and how they could be represented in this model. And we need that tool before we can say what bundle of goods David prefers to another bundle of goods, or which bundle of goods Vivi prefers to another bundle of goods. But that's out there in the future, nothing you need to worry about at this point. These don't, the first two are wrong. The second two are defensible in this model.